intact with the real field of the what you call water level. So that is how the controller, sensor, and the activation. This is how the total closed loop system we have already implemented, and we do conduct a lot of 24 hours marathon in consultation with the industry. The students carried out the 24 hours project, like morning 10 o'clock we announced the what you call use cases. The next day 10 o'clock 10 a.m. we close, and we have a three thrice out of 24 hours, like end of 8th hour, end of 16th hour, and end of 24th hour, three thrice we conduct the evaluation. So this is one such event. This is the second event. So some of the students of other college and even our own students also take part as a team, and the industry persons also come over here and evaluate. They get a lot of opportunities. This is the third such event, and this is the fourth. Like that, we conduct several IoT hackathons. We have a lot of research directions, like smart cities, intelligent transportation, and remote telemedicine using wireless body and network. And we have support with the Quantigi, and we have a W band because we have a IEEE 800.15.4 IPv6 based 6 low band support we have in Quantigi. And I'll just run through the example, then I will show you the demonstrations at the end. That's what the today's focus. So we have a IoT based tracking of localization. That is also very interesting use case, and smart metering, and precision agriculture, and industry 4.0, and 5G wireless with IPv6. That's what the order of the day. This is actually the real simulator. Puja is the emulator, and we have 5G support with NS3 from nsnam.org. Omnet++ supports WSN. Proprietary tools like a CallNet, MATLAB, and we have a NetSim, and we other platforms like WSN platforms, and small and medium scale application. You can use your own Raspberry Pi or Arduino or any other Intel controllers, and you can develop your own applications. So I just tell you, this is what the Quantigi is a very popular operating system, which is open source. Kuja is the emulator. The difference between simulator and emulator is, simulator we can only do the thoroughly software instructions, but emulator supports hardware also along with the hardware support along with the simulation, so we can able to thoroughly verify and validate. So Kuja is one such emulator, which is very prominent candidate in IoT context. To I think participants, you may take a photo of this. This in Linux environment, or in Windows means we have to put a VM player, and you have to put a dual OS Linux, and we have to run through some of the prerequisite this, and we have a very popular MSP 430 and related development Java and AVR controllers, and all these prerequisites we have to install. Sudo apt-get install, and we have to download from GitHub. We have a Quantigi 2.6 and 2.7, these two standards, and now we have a Quantigi NG. With respect to NG is next generation, just a long range support with respect to IoT. And if you see in this particular location, we could see Quantigi 2.7 tar z is a download, and using this command in terminal we have to extract and cd into this, and run. We'll able to get it. I will show you after a while. And now to have the support of a real exploration of IoT, we need to have a 5G spectrum. Only then we could be able to accommodate bandwidth support, and that many number of IPv6 addressing support. So the specs with respect to 5G here are, with respect to 3G phone, if you look at it the way back, it supports only 2 Mbps when you are static. When you are moving, it gives only 384. And you might have aware of HSPA, HSDPA, that's a downlink packet access and uplink packet access. This is what the third generation. Fourth generation, it ensures provide 100 Mbps, and it is thin, sleeky than the 3G phone, and it supports IP transport and affords intelligence at every stage. If you look at 5G, it's the major phase of the mobile. We have 10 times faster than the 4G, and the supports of data rate minimum 1 Gbps to 10 Gbps. Just imagine, with 2G GSM, we have only around 9.6 kbps in terms of 1 gigabits per second. Even in the movie, if you look at 400 or 700 MB movie, you can how best speed we can able to download and stream, and that's the power of 5G. low power, low cost than the previous version. And in terms of network side, it has come already, and it is yet to get mature level in the market. And Docomo, and people will be able to experience 5G. Yes, definitely. And 3G and 4G handset does not run 5G network. No, 5G requires new chipset that is having capable of supporting 10 gigabits per second in around this range. So with the 4G and 3G runs only at the fractional speed, we cannot able to really experience the to this very known to you. And 4G it supports 100 Mbps, and when you are moving, and when you're static it gives 1 Gbps. Here one minimum of 1 Gbps to 100 sorry 10 Gbps, and it supports yeah, devices with the AA support. And early to that we have only WW. Now we have 4 Ws, that's a wireless world wide web. That is what the intelligence we have in the 5G. And with respect to 5G architecture, if you see, and we have this is a open wireless architecture in the physical and data link layer. And network layer has been split logically into two segments. One is the lower network and upper network. And we have a open transport and application. This is what the layering scheme of the 5G. And this is a open the this is like a OTL, that is a transport layer. If you see open transport layer, that is what that's the meaning of transport layer plus session layer, the support. And we have all the radio access networks like GSM, GPRS, UMTS, LTE, WiMAX, and all of them will be able to support. Because if you see IoT without the network, we cannot able to really handle the communication with respect to device connectivity, and into the gateway, and the intern to the cloud. And we need to have a broadband support. And we have a so-called IP core with respect to AI-based nanotechnology, cloud computing. And with respect to global applications like defense, transportation, communication, medical, government, banking, it is going to be experienced in all parts of the globe in different context of the application. And applications here are wearable devices with AI, 5G iPhones with sixth sense technologies, global networks, voice over IP, radio resource management, media independent handover. So again, a seamless handover is challenging aspects with respect to existing context. The 5G provides that support. If you see with respect to overall, we have a people normally says a MIMO, that's what you call real MIMO. That's a massive support and dense and moving networks, multi-hub, and device-to-device context. So if you see the traffic is every day, it is keep increasing. Now current 1,000 times, that is in 10 years down the line, it is going to be avalanche level. It's additional traffic keep increasing, because every user is now having more than one connection, at least minimum 2 or 3 connectivity. And all the devices will have a IP and internet, and connecting to that we'll have a traffic volume is so huge. Connected devices, all of them, mobile phone camera, your street light camera, even a ship, and a plug point, all of them will be having IP with intelligence. That is why the 50 billion devices it is expected to be in the web, that is forecasted by Cisco. And large diversity of use case and requirements, car to car communication. So if you see all these things, which is a well-known popular so-called we have a METAs, that's like we have a ITA, that is here mobile and wireless communication enablers for 2020. Their scenario is to have all these things like accessibility, delay, reliability, device coverage, ubiquitous computing, super real-time and reliable connections, best experience, and great service, amazingly fast, with the highest bit rate and a low delay. So this is what data volume is going to be 1,000 times higher than, and a high number of connected devices 10 to 100 times. And the typical end data rates is going to be 10 to 100 times more than what we have. That's up to 10 Gbps. We will be able to have a few milliseconds gap on delay only. And the battery lifetime is going to be 10 years. That is like that's unimaginable. That's what is the focus. So with all these things, we are going to have a backward compatibility with 3G, 4G, and Wi-Fi. On top of that, we are going to build all the massive MIMO and UDIT networks, and moving network like PANETs, like flying or dark networks. So this is what the overall requirements. Data rate the range from 1 to 10 Gbps, capacity terabytes, that is spectrum high, energy with respect to 10% of today's consumption, less only, that is latency reduction is 1 millisecond, device to device connectivity, reliability, coverage, battery, and device per chip area. All these things are the requirements of the 5G. We are going to handle it with this. So with this note, I move to the today's part, that is in terms of quantity. Is this visible to? Is this visible?
Yes, sir, it's visible, sir.
Yeah. Think the second day I initially Yeah, with respect to today's context, we are going to discuss in terms of the IoT, in terms of the simulation aspects. We are going to talk on emulations using Conchiki. This is very popular simulation platform. So what are we going to do with this? That is, we will explore as part of today's class. We will be completely exploring on protocol stack of IoT with the 6LoWPAN, RPL, QoP, MQTT. All these things are. Hello, hello. Somebody unmuted. Can you,
Rupa ma'am,
uh,
just mute your audio, ma'am.
Ruba ma'am, can you mute your, yeah, thank you.
Okay, sir.
So far comfortable, all of you? Hello?
Yes, sir, it's now okay, sir. It's not a problem.
Yeah. So we have a protocol stack, and we are going to see the quantity with the Kuja emulations. I think I have to switch over to Linux. I'll after the theory part explanation, I will switch over and show you the demo there. And we have some of the applications like QoP and MQTT, constrained application that QoP, MQTT, message queuing and transport telemetry. So let's see quickly with respect to, as I said already, about the simulators and emulators. If you see with respect to IoT operating systems, we have a Quantigi, TinyOS, Linux, RIoT. So Quantigi is so popular, and a lot of open source support we have in the market with respect to it, with its consumption of the RAM and ROM, and many features like support of C, C++, multi-threading, and MMU unit, memory management unit with respect to microcontroller with memory management unit without that support, modularity, real-time services. So TinyOS is a candidate which was smelled by people in way back 20 years back. That is for a wireless sensor network. Now no support. It is already outdated, deprecated one, and no support for IoT. That is outdated one. So Quantigi so popular. We have a one more high powerful RIoT that is upcoming and becoming so popular one, and but we have only less support. So we will be even to some extent, even we will migrate to that. In prior to that, in between we have a Quantigi NG, that's next generation has come. So I will run through and show you the steps. So if you see the steps for the NG, I'll just show you after the theory part. So this is what the steps which I already told you to, how to install, and I will show you in the simulation environment after switching over to Linux environment. So if you see the protocol stack, as I was talking to you, in the sensor layer, we will be having solid state switches, electromagnetic switches, infrared, catalytic and photo ionization, accelerometer, gyroscope, GPS, electrochemical sensors, embedded controller. On top, we have a network. You may use Wi-Fi or Ethernet Shield or ultra-wideband, Zigbee, 802.15.4, or with the PAN coordinator, 6LoWPAN, wired networks. So these are all the what you call sensors along with the connectivity. And from the sensor board to the gateway, we have a GSM. It's a very old one. LTE networks are LTE is so popular. Even we can use Wi-Fi with a small coverage. Yeah, if it's a Ethernet for a we can use that also. So we have a microcontroller with gateway support we have. On top of that we have a gateway, and on top of the gateway we have a middleware layer, that is what operation subsystem building, base station subsystem with respect to GSM aspects. And with respect to IoT aspects, we have analytics platform, we have a statistical analytics, mining, IoT motion analytics, text mining, in-memory analytics, predictive analytics with respect to data, and in all aspects, data governance, analytics, storage, quality management, security aspects of the data, BRM and BPM, that's business flow, workflow, and business rule. All these things we have a middleware architecture. This is what we call it as management services, middleware architecture. On top, we have a energy, transportation, healthcare, retail, fleet management, asset management, supply chain, people tracking, surveillance. These are all as many applications you can build, and you can have. That's what is the applications with respect to protocol stack is concerned. If you see why 6LoWPAN is required, if you see here, as I told you already, if I'm not wrong, the 6LoWPAN I have introduced already in the context which I spoken already in the yesterday's class. We have a, this is what the adaptation layer with respect to physical and MAC layer. That's with respect to every network, they have their own physical layer and MAC between I. So this is what I am just meaning, that's adaptation layer. So why do you need this adaptation? That is what the question here. Why do you need this adaptation? We have a no method exists to make so-called we have a no method exists to make run over the 802.15.4 network. So we should have this 6LoWPAN, that's a mapping one, and IPv6 MTU size is this much, and none of your packet will handle this much huge size of the data bytes, and not all ADAC routing may be immediately suitable for 6LoWPAN, because DSR, dynamic source routing, DSR will not fit packet, and AODV needs more memory, and security for multi-app needs it. Because of these reasons, to have a to resolve these issues, we should have a 6LoWPAN, and based on 6LoWPAN, we are going to run through demo with RP. We mean to say that it's nothing but routing protocol for lossy networks. I'll show you demo after a while. And top of that, we have a so-called constrained application protocol. That is a protocol which is going to be, if you see with respect to the that's what I have told already. If you look at with respect to problem with the end-to-end networking, resource constrained IoT devices need adaptation. That is why we need to have either SQAP or MQTT. So need adaptation for mapping function end-to-end global IP networking, manages all large number of devices to handle varieties of IoT protocols. So you will
Is
see
it
the
audible?
all the message transfer unit differences,
Yes, sir.
simplified and full protocol stack. So if you see here, the constrained application protocol comes with the RFC 7252, and this is what the co-op protocol. What we mean to say, we wanted to have a year uh, as one of the prominent candidate. If you see on top of the 6LoWPAN, we are going to have a TCP or TCP UDP. On top, we have co-op. These two are the adaptation. One is 6LoWPAN, other one is co-op. We can use the advanced version of co-op is we have a MQTT. So that is what I really want to cover up here. If you see here quickly, the co-op, um, one is about for to support of IPv6, and to handle the routing, we need to have a routing protocol for IPv6 support, and to have a so-called RPL. So we should have the routing protocol for lossy network. And the next adaptation is co-op. We cannot use huge address size HTTP, because that is not going to be a prominent candidate with respect to the context of the end use application. So we need to have a so-called lightweight protocol for constrained device environment. So we have to use so-called co-op. Yes, the constraint application protocol. This is again what you call supported by consortium IETF. That's a Internet Engineering Task Force (RFC) with a 7252 standard. It is a machine-to-machine application. It supports RESTful architecture like HTTP, low header overhead than HTTP. It is binded with a IPsec layer of IPv6 or even a device transport layer security DTLS, reliable unicast and best effort multicast support, and built-in resource discovery. So if you see with respect to constraint one, this is what the real support. And if you see with respect to the overall, we have a Zigbee with a 802.15.4 physical and MAC layer. On top, we have a 6LoWPAN, that is adaptation layer for IPv6 support, and your routing support, that's RPL with IPv6, UDP, and co-op transaction, co-op methods. That's what we are going to see here. Co-op stands for, what is co-op stands for? Co-op comes under application level protocol. What is co-op stands for? Hello? Can you, anyone tell what is co-op stands for? Hello? Am I audible? Hello?
Yes, sir, it's audible, sir.
Yeah, what is co-op stands for? Co-op stands for? What is the expansion of co-op? Can you anyone unmute and talk? I've explained, right, what is co-op stands for? It is projected also. What is co-op stands for?
Participants, kindly
Hello?
unmute your audio and you can tell the answer.
It is nothing but constrained application protocol, right? Because we cannot use a well-known popular application protocol HTTP. HTTP header size, we have a HTTP get, post, and other additional options, header, and it's so huge we cannot bound to use that for IoT applications. So we have to use this co-op. So this supports like co-op methods and transaction. If you see like a conformal message, non-conformal, acknowledgement, read, transmission. So these are all the message, what you call identity. We have a co-op methods like get, post, put, delete, as like with HTTP, but these are all lightweight with embedded with URI. You know URL, right? So uniform resource identifier with the URI, it is binded already. So if you see the left one is synchronous process. This is the transaction between client and server. I told you already, HTTP, without HTTP, you cannot access internet. We should have HTTP request and response. The same context here, we should have a co-op request and response. This is the co-op with respect client get and acknowledgements and acknowledgement for the acknowledgement, and you get the response, right? This is what the synchronous transaction. Asynchronous, you can see with respect to with you need not be with the same sequence or need not wait for the acknowledgement. You can go transferring multiple messages without getting even acknowledgement from the other end. So this is asynchronous. RPN transaction, a process which does not have a parent. That means a non-parent child process. This is a orphaned transaction. We may not know who is the real client, who is the real server. Maybe with the multi-hub, multi-client server, this is the sample scenario of orphaned transaction. So if the co-op demo also, I'm going to show you in a while. So if you could see here the steps to be followed here. So can you? I think I'll open and show there also. We are going to see the co-op demo also as part of the demonstration. So let's see here. We are going to see about the demonstration. This step along with the demo, I'll show you. So we can, as like HTTP message, we will be going to see a co-op colon slash slash. Hope you are aware HTTP colon or HTTPS colon slash. Here we are going to see the co-op with IPv6 address and with the sensor or a button, we can able to handle the end devices, and remotely we can able to monitor and control. So the next application is MQTT. That is also a application protocol which supports like resource broker architecture, like message queuing for transport telemetry, and we have this works basically with broker architecture like a publisher subscriber messaging scheme. So if you see broker server, active message queue, and client Apache or Python based implementations. So we can see here it is a transport message queuing transport telemetry, that's MQTT, and it's a lightweight messaging protocol for M2M, similar to COAP, but it supports broader coverage of the IoT devices and telemetry support we have, and this is developed by IBM basically and become open standard now. It is anybody can use based on publish subscribe mechanism basis. You can see here the real power of this basic. It works, as I said already, it works on broker architecture, like a broker and connected clients. So we have a, all the intermediate persons are called broker, receive subscriptions from the clients on the topics. Broker receives message and forwards them to the multiple clients who subscribed or who published and gives the acknowledgement accordingly. It various brokers bridges the configuration with the MQTT. So if you see with respect to here, we are bound to use this publish subscriber model, and the producer sends is nothing but publish. That's publication on a subject or any resource. Consumer server publishing, broker intermediate person, the consumption, that's a consumer, that is a publish, that is a subscriber. Publish subscriber architecture style followed. Subscriber is nothing but consumer end. So if you see MQTT publish and subscribe, it goes with hierarchical with a wildcard hash include plus. So building plus for a room and floor. That's how it goes. So if you see here the sequence, publish and acknowledgement, publish with the resource ID, acknowledge for that QoS, and publish and acknowledgement for that. So this is how we have a device with the broker. So you don't have a direct device to device. Here is device with the broker. So this device also binded with a broker. And what I wanted to say is it's inquiry, and this is CMD. That is nothing but you can see, as I was talking to you already. This is asking to tell as this a tell command. Here you can see the inquiry command INQ.